It's about 70 grams. Okay. But from that, we should be able to get a plot that ties together our deflection from equilibrium and our spring, the force of the spring. And that will let us know the spring constant. With your graphing calculators, right, you know, do the L1 and L2 thing and put your data in and you will get a plot. Okay. Just remember the X's on this got to be L1 and the F sub S has to be your L2. Okay. You'll get it. You'll see it's really nice straight line, and the slope of that line is K. Okay. All right. So you have to know that, otherwise you can't do this. The meat of the problem is to then set this thing into motion, not with your maximum weight hanging there, but something less than that. Set it into motion by, see right here, it's in equilibrium. The force up by the spring is bouncing out the force down. You don't really want it to rub on this. Whoops. I'm going to set it into motion by pulling it down a little bit, and then it's going to start oscillating up and down. I want to record the bottommost point and the topmost point because those are the easier parts to analyze the system. Okay. What you want to be careful of is, you'll notice the system is damped. Eventually it will just go down to nothing. So the lowest point is easy to grab because you can see it where you're holding it steady. As soon as you let go, try to get the highest point as well, because over time those will both diminish. Okay. I had something for you guys on this already drawn out, so let me get that out. So think about the energy transformations that are taking place right now with your in that spring. What types of energy it has at the top, bottom, and middle.
Maybe I had to reorient it, just theoretically.
Here's your spring as it's oscillating up and down. Okay. Notice, let me stop this for now. What types of energy does it have, the system, at this point?
Potential.
Elastic and gravitational. Right? Both types of potential energy. Even though it's not moving, right, there's still some energy stored that's just waiting to be released. If we got rid of that hanging mass, it would spring back up. Right? So when I pull it down even further, what happens to the energy?
You become elastic energy.
Yeah, the elastic goes up. Where did that extra energy come from?
The potential energy being converted.
No, it doesn't come from any other potential. Well, you did lose gravitational potential, but there's more. There's more to it than that. I had to do work on it to pull it down. Yeah.
Cool, yeah.
So now I've got more energy in this system. Okay. Now I release it. This point in the middle is really going to be of interest to us, hopefully. Give me that. Smart board is sweet slow. So right right here is where it would be just hanging freely. It's going to go up above it and then come back down. On the way towards it, what can you say about the force of the spring as compared to the force of gravity? On its way up, Jamie.
It's created.
Okay, how do you know that?
Because the force is upwards towards the spring surface. So
Yeah, it's accelerating upwards, right? So it's gaining speed as it goes towards the center. When it gets above that, right, it eventually stops. So what must be happening from here to there? Yeah. The force of gravity is now smaller. It's not smaller than it was here, but it's, I'm sorry, the spring force.
Pardon the interruption. Ms. Donnelly, can you please call the main office? Ms. Donnelly, please call the main office.
Anyway, why is this spring force less up here? What's happened? Where'd the spring force go? I mean, why did it change? It was way bigger over here, now it's smaller. Why is the spring force smaller?
Probably because the more you compress the spring, the less spring force there is.
Right. That deflection from the equilibrium position is smaller now. The X is smaller. And so there's going to be less of a spring force until you get to this point. And then it's going to start accelerating back down. Okay, so every time it's going towards the center, it's going faster, it's accelerating. So then what can you say as far as the energy is concerned? When it's at the center, what type of energy is it at its max? Kinetic, yeah. Right? It's picking up speed, then it hits there, and then it slows down. It picks up speed, hits there, slows down. So it's going as fast as it can, right in the middle. So that's where you've got, oh, it's got it right here. Kinetic energy is at its max. Okay. What types of energy does it have up here, at the highest point? Give me one type of energy it's got at the highest point.
Me?
Yeah.
Oh, I don't know.
What type of energy gets bigger when you go higher?
Higher?
Uh-huh.
Is it? I don't know.
I think I heard you say. The gravitational potential energy gets higher.
Oh, I said it.
Right? Yeah.
Because I didn't know it was right.
Okay. All right. So here you're at your maximum amount of gravitational potential energy. Let's say the lowest point we're at, the gravitational potential energy is 0. Let's use that as our reference point. It makes things simpler. Right? So when we get back to the lowest point, all the gravitational energy is gone. All right. Does it have any other types of energy at the very top?
it has a smaller elastic.
Yeah.
Like
It
negative.
still has elastic potential.
Because below it's without energy.
Right. This point right here is where it would just be hanging without any load. Right? And it's still below that. So it does have some elastic potential. It looks just like my G. But that's at its min. Okay? So bear in mind, you still have, even at your highest point when that's oscillating, you still have some elastic potential. And then when it gets to the bottom point, Rochelle, what do you think? What kind of energy does it have at its bottom point? Elastic, yeah. And that elastic is at its max. Okay? How much kinetic energy does it have at the bottom, Kathleen? when it stops and turns around. What do you think? How much kinetic energy do you have when you stop? 0, yeah. There's no kinetic. How much gravitational potential energy does it have when it returns to its lowest point? I'm sorry? So we started here and then it returned to that position. How much? Yeah, and we're calling it that minimum 0 at that point. Okay, so check it out. At the bottom, we're assuming that it only has elastic potential, and at the top, we're assuming that it has both of those. Now, it's your job to tell us whether or not the energy is being conserved experimentally. Okay? I'll give you a little bit of time to do that. There are 8 setups. And we've got how many? 3, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We're going to get into groups of 3. 2 groups can have 4. Be careful with the springs. The springs are here. All the equipment you'll need is up here.